Hi everyone, and welcome to this grade 9 mathematics lesson where we will be exploring equations of linear graphs. My name is Ms. Donnell Phillips. Let's get started. In our previous lesson, we were able to identify the equation of a line by examining its graph. We can also identify the equation of a line without actually seeing the graph. This involves a little bit of calculation, and that is exactly what we're going to be exploring today. Recall that the general form of writing an equation of a straight line is y equals mx plus b or y equals mx plus c, where the m represents the slope or the gradient and the b or c represents the y-intercept. So we're going to go straight into working a few examples, and you could see how we could actually get the equation of a line without actually having a visual representation of the graph. First problem, find the equation of the line that passes through the pair of points 6, 3, and 4, negative 2. The first step would be to calculate the gradient of a line. And we know that we could use a formula which is m is equal to y2 subtract y1 divided by x2 subtract x1 to calculate the gradient. The next step requires us to select one of the points and substitute it in the general form of the equation to find the y-intercept. And that's exactly what we're about to do. So it says, find the equation of the line that passes through the pair of points 6, 3, and 4, negative 2. Now remember, when we want to get the equation of a straight line, the first thing we need to do is to calculate the gradient. So that's what we're going to do. We're going to calculate the gradient first. M is equal to y2 subtract y1 all over x2 subtract x1. Let's identify our x1, x2, y1, y2 points first. So the first point that we're given is the 1. So this is going to be x1 and this is going to be y1. The second point that we're given would be the 2. So this would be x2 and this is y2. So all we have to do now is substitute. y2, negative 2, subtract y1, 3 all over x2, 4 subtract x1, 6. So m is equal to negative 2 take away 3 is equal to negative 5 all over 4 take away 6 is negative 2. Now we know when we're dividing two negatives, they cancel out and they become positive. So the gradient of this line is m is equal to 5 over 2, or we could say m is equal to 2.5. Good. After we would have calculated the gradient, the second step in order for us to identify the equation of this line is to select one of the points and substitute it into the general form of the equation to find the y-intercept. Remember, the general form of the equation is y equals mx plus c. So when we select any one of the points, remember the points are written in the form xy, so we would already have our y value, we would already have our x value. We just calculated our gradient, and the only thing that is missing from the equation is the y-intercept. So we're going to use the first point, point A, as our x and our y values. So since y is equal to 3, we're going to start. 3 is equal to, what is the gradient? 5 over 2 times x, and x is 6, plus c. Remember, we're doing this so that we could find the value of c. So let's work out this part. We have 5 over 2 multiplied by 6. So we could just write this as 5 over 2 multiplied by 6 over 1. In order for us to take a whole number and write it as a fraction, we need to just put the whole number as the numerator and the denominator as 1. So we multiply. 5 times 6 is 30, and 2 times 1, 2. So this is equal to 30 divided by 2, 15. So we have 3 is equal to 15 plus C. Now if we want to find C, what C is, how could we get rid of this 15? In order for us to get rid of the 15, because it's a positive on this side, we could transpose it. And when we transpose any positive number or any positive term, it becomes the opposite of positive, which is just negative. Or if it's added and we transpose it, it subtracts. So since we have 15, a positive 15, when it goes across, it becomes negative 15. So we have 3 subtract 15 is equal to C. And 3 take away 15 is equal to negative 12. So negative 12 is equal to C. Now the final step, as you would have mentioned before, after we would have gotten the C value, which is the y-intercept, and the gradient, we could now rewrite using the general form. We now write back the equation, but we now have to include the gradient that you would have found and the C value or the y-intercept that we would have found. So the equation of this line, given these 2 points, is y is equal to m, and the gradient is 5 over 2x plus C. Now because it's a negative 12, we don't write plus 12. We have to keep the value. So this is just negative 12. So given the 2 points A equals 6, 3, and B equals 4, negative 2, the equation of this line is y is equal to 5 over 2x subtract 12. Next example, find the equation of the line that passes through the points 4, 2, 5, 4, and 6, 6. Again, all we need is 2 of the points. We're going to first calculate the gradient and then select any one of the points to substitute it in the formula to calculate the y-intercept. Now remember, the general form for the equation of a straight line is y equals mx plus c. So all we need is the gradient of this line, the x value from one of the points, and the y value from the same point. We could find c, and then we could write the equation of this line. Now in this example, we're given 3 points. We just need 2 of these points to be able to calculate the gradient. So it doesn't matter if you use the point 4, 2, and 5, 4, or 4, 2, 6, 6, it doesn't matter. So we're going to use the first 2 points, 4, 2, 5, 4. Again, first thing we need is to calculate the gradient. Formula, y is equal to y2 take away y1 all over x2 take away x1. So this is our x1, y1, x2, y2. Substituting, m is equal to 4 subtract 2 over 5 subtract 4. So m is equal to 4 subtract 2, 2, 5 subtract 4, 1. So the gradient is equal to 2. Now that we have the gradient, we could take one of the ordered pairs that we're given as for the x and the y value. Using the same gradient is equal to 2, we could find the y-intercept. So let's use the first ordered pair that we're given. Y is 2, gradient 2, x is 4 plus c. So 2 is equal to 2 times 4 is 8 plus c. Now we want to find c again. We have to transpose the 8 And when the 8 goes across, it becomes negative 8. So we're left with 2 subtract 8 is equal to C. And 2 subtract 8 is negative 6. So negative 6 is equal to C. Now that we have the gradient and the y-intercept, the equation of this line is y is equal to m x take 6. Next example, given the line y equals 2x plus 3, write down the gradient of the line, that's 1, 2, the coordinates of the point at which the line cuts the x-axis, and 3, the coordinates of the point at which the line cuts the y-axis. Given the line y equals 2x plus 3, write down the gradient of the line, the coordinates of the point at which the line cuts the x-axis, and the coordinates of the point at which the line cuts the y-axis. So the equation is y is equal to 2x plus 3. Again, we can just look at the equation and identify the gradient. So in this case, in this example, we can see that the gradient is positive 2. So gradient 2. Next, we want the coordinates of the point at which the line cuts the x-axis. We're going to do this one last. We want the coordinates of the point at which the line cuts the y-axis. First of all, how could we tell where this line would cut the y-axis? What are we supposed to look for? This value here. So we know that this line is going to cut the y-axis at positive 3. So since C is equal to 3, the coordinates of this point, remember coordinate means it has to be written in the form x, y, right? So if it's cutting the y-axis at positive 3, it means that x has to be 0 while y is 3. So the coordinates where this point, if we were to sketch the graph, we would have to identify positive 3 is going to be somewhere there. And this is the point that this line is going to pass through and cut the y-axis. Now we need to find where this line cuts the x-axis. The first thing we need to do is to substitute y equal 0 into the equation. So wherever we see y in the equation, we're substituting it with 0. So this becomes 0 is equal to 2x plus 3. We have to make x the subject of the formula after we would have done this. So we're going to take across a positive 3 and it becomes 0 subtract 3 is equal to 2x. Negative 3 is equal to 2x. We don't want 2x, we just want x. So we will transpose the 2, and because the 2 is multiplying, these two are being multiplied, it's actually 2 times x. When the 2 goes across, the inverse of multiplication is division. So we would end up with negative 3 divided by 2 is equal to x. So again, what is y equal to? Y is equal to 0 and x is equal to negative 3 over 2, or if you want, you could write it as a decimal, which is negative 1.5. So negative 1.5, 0 is where this line would cut the x-axis. 0, positive 3 is where the line would cut the y-axis. Final example. Given the line y equals negative 2x subtract 5, write down the gradient of the line, the coordinates of the point at which the line cuts the x-axis, and the coordinates of the point at which the line cuts the y-axis. So the final example, given the line y is equal to negative 2x plus 5, we have to find the gradient and the coordinates of the point at which the line cuts both the x and the y-axis. Again, we could look at the equation and identify the gradient of the line. So in this case, the gradient is negative 2. Now we want the coordinates at which the line cuts the x-axis. First step is to let y be 0 and then substitute it into the equation in order for us to solve for x. So we're going to have 0 is equal to negative 2x plus 5, carrying across 0, subtract 5 is equal to negative 2x. Negative 5 is equal to negative 2x. Negative 5, when we carry across the negative 2 because it's multiplying, it now divides. So we have negative 5 divided by 2 is equal to x. These two subtraction signs, because they're dividing, they're going to cancel out. So we just left with 5 over 2 is equal to x, or we could write it as a decimal. 2.5 is equal to x. So the coordinate where it cuts the x-axis is x is equal to 2.5 and y is equal to 0. Same thing, we want to find where it cuts the y-axis. All you need to do actually is just to look at the c value, and we know that it cuts the y-axis at 5. So we know that we're working to get 0, 5, right? But let's just follow the same method to confirm. So since we want to know where it cuts the y-axis, instead of substituting y equals 0, we now substitute x equals 0. So we're going to substitute x is equal to 0. So let's go. Y is equal to negative 2. Remember, x is now 0 plus 5. Anytime we multiply any number by 0, the answer is always 0. So negative 2 times 0 is 0. So we're left with y is equal to 0 plus 5. Y is equal to 5. So again, x is 0 and y is 5. So 2.50 is where it cuts the x-axis, and 0.5 is where it cuts the y-axis. So to summarize today's lesson, to calculate the equation of a line, we must first calculate the gradient and then select one of the points and substitute it into the general form of the equation to find the y-intercept. Any point where the line cuts the x-axis has a y value of 0, and any point where the line cuts the y-axis has an x value of 0. This has brought us to the end of this grade 9 mathematics lesson, where we would have explored the equation of a straight line. My name is Miss Donnell Phillips. See you next time.